The efficiency and cost of data that we send through satellite in the last few years has become friendly 1,000 times.
Omarichet is an Nandi word. It means the circular cattle enclosure. This is where most African communities used to protect and store their livestock at the center of a homestead. So Omarichet came by as an idea whose time had come.
I wanted to be an astronaut. I wanted to go to the moon when I was young, and I had the privilege to meet an astronaut who was on Apollo 17, and he went to the moon and he drove the lunar buggy. His name was Jack Schmidt, Jack Harrison Schmidt. That experience of meeting someone like that very much inspired me to take up an interest in space and physics and science. I think satellite has got some kind of a bad reputation, and it has a legacy of times when data was expensive and people remember it as being expensive. But there's a lot of innovation going on in the satellite space.
However, the vastness of Africa makes it difficult for traditional terrestrial networks to reach everyone, leaving millions of people without access to the internet.
Africa is 20% of the global landmass, and in Africa more than 60% of the population are youth. At Omarichet, we plan to launch satellites that is going to rotate on equatorial orbit around Africa. First phase of the satellite constellation is going to focus on providing internet connectivity, and then subsequent launches will be followed by modular nanosatellites that are going to provide essential and core services needed in Africa.
Satellite-based services are many, but not limited to Earth observation, agriculture, financial services, government, defense, and disaster response.
It's really great and exciting to see that the first mission that Omarichet undertook was to develop this training kit, a satellite nanosat training kit that can be afforded by African institutions.
At Omarichet, we have taken a further step in manufacturing open source, affordable and modular nanosatellites that meet and exceed the demand for nanosatellite training and mission design prototyping.
When I was a child, I used to think about and draw a lot of satellites, rockets, spacecraft. But then people would tell me, you're crazy. How are we going to do this in Kenya? We barely make our own toothpicks. So I decided to join aerospace engineering in university. The course was still pretty fresh in the university, so we didn't have a lot of content and materials. And that's when I realized that there's a gap in the education sector in training engineers in so many ways of practical hands-on experience in satellite engineering. And eventually, with the hard-working lecturers and so on that we had, we were able to, of course, finish. And that's when I thought to myself, okay, what next? Then I came across Omarichet, and they had a project called Omarichet's EduSat, which is basically a kit that's almost, if you look at conventional kits in the market, they cost upwards of $10,000. The Omarichet EduSat kit was looking at below a tenth of that, yet achieving way more using conventional materials and prototyping as modularity, as well as other concepts that minimize cost and advance reliability. If I had this as a child, it would have really helped me to also understand and learn satellites earlier.
Omarichet's EduSat consists of a 1U architecture that familiarizes learners with existing satellite subsystems.
What we have here in the EduSat, we have a variety of systems, subsystems that allow our nanosatellite to function as nearly as a commercial satellite. We have the power supply system, we also have the onboard computer, we also have a communication system, and last but not least, we have the ADCS system, which is the attitude determination.
What we're doing here is fully designed and built by us, and the only way to do that was to make sure everything from the electronics to the structure were put together here, designed here, and tested here.
One thing about this nanosatellite is that it can be customized for whatever level the learner is at.
Omarichet EduSat has integrated Colibri web server that has learning and training material customized for every learning level. Beginner, that is high school students. Intermediary, for university students in engineering and STEM. Advanced training for practicing engineers, academia, experts, and personnel seeking upskill in satellite development.
Our Raspberry Pi platform runs Colibri, which is an amazing, dynamic, open source software platform. That means that Essentially, once you connect to the internet, it downloads all the data that it needs. Universities and schools in urban areas, you can have access to all our learning curriculum wherever you are.
This is the opportunity that Omarichet is really out there to enhance.
The ability to design and launch satellites has become an essential skill for scientists, engineers, and entrepreneurs alike. And having access to educational satellite kits can help to foster the development of these skills. Omarichet, possibilities in space.